to go through with you will be these the series of basic equations. The series of basic equations that we are going to look at, which is going to represent the basic equation for a general 3D body under 3D elasticity, under theory of elasticity. So we have looked at the stress components, which is a kind of tensor and its components under this coordinate system. Okay. So these 6 stress components, there are 6, are the first set of variables that we need to determine, I think, in an analysis. Okay, the other set will be strains, and the third set will be displacement. So the stresses, this 6 component is the first set of variables that we need to solve. Okay, and the first set of equations, the first set of equations that we need in order to solve a problem is equilibrium equations. Equilibrium equations, and equilibrium equations are represented by these 3 sets of equations, which is a partial differential equations. So this first set of equations, this second set of equations, and this third set of equations. So this Rx, Ry, Rz is the component of, these are the component of body force in X, Y, and Z directions. So in X, Y, and Z directions, we have the component of the body force. So if we have a body force R, so expressed in component X, Y, Z, these are the component Rx, Ry, and Rz. And these 3 equations are actually equilibrium equations of forces in X, Y, and Z direction. So these are equilibrium equations in X, Y, and Z direction. So we derive this by considering equilibrium of forces of this infinitesimal volume in X, Y, and Z direction, then we will get this. Okay. Now, let me go to the next set of equations that we need to know. So the second set of variables that we need to know other than stress. So we already have stress, which is sigma X, sigma Y, sigma Z, tau XY, tau YZ, and tau ZX. Okay. So this is the first set of variables. The second one is displacement. So displacement, if it represents what happened to one point before loading and after loading. So before loading, it is at the coordinate direction, coordinate X, Y, and Z. So after loading, it moved to a new directions. And the vector which represent the movement of this from before applied loading to after applied loading is what we call the displacement vector U. And if we introduce this coordinate system X, Y, and Z, so the displacement is a vector, so it has 3 components that we can write down here as U, V, and W. So this is a displacement component. So this is the second set, the second set of variables that we need to determine. The first one is sigma, the second one is displacement. The third set is the strain. Okay, this is the third set of the variables that we need to determine strain. Okay. So strain is represented using the symbol epsilon, epsilon X, epsilon Y, epsilon Z. And then another 3 is gamma, XY, gamma YZ, and gamma ZX. So these are the corresponding 6 strain components that we need to determine. So together with stress 6, displacement 3, and 6 strain components, we have altogether 15 variables that we need to determine. So Strain components are also divided into normal strains, which is associated also with the sigma x, sigma y, sigma z, okay, sigma z. So this is associated with this normal strain. So you have normal strain, epsilon x, epsilon y, epsilon z. Then there's only one subscript here. Same thing as what we adopted here. Okay, only one subscript for normal stress and normal strain. And the same thing for shear stress. We have tau xy and so on. We have also this corresponding shearing strain, which is represented using symbol gamma. Gamma xy, two subscripts now, xz and yz. And this engineering shearing strain also, what we are using here, we call it engineering shearing strain or engineering shear strains. Why we call it engineering shear strains? Because there are some strains, especially strain tensor, the component of strain tensor, which is defined differently. But here, what we are going to use here is the engineering shearing strain. So this is the third set of variables that we need to determine. Okay. And displacement and strains are related using these strain displacement relations. So you have 6 strain displacement relations, which is shown here, relating the strain to the displacement using these 6 partial differential equations. Using these 6 partial differential equations. Now, if you look at these equilibrium equations, 3 here, there are 3. Okay. Then you have stress, the number of stress that we have is 6, the number of displacement that we have is 3, the number of strain components that we have is 6, and the number of equations that we have here is 6. So stress 6, displacement 3, strain 6. So the variables that we need to determine, there are 15. Equations, we have equilibrium. So this is 3. Strain displacement, we have 6. So these are 9 here. So we need another 6. We need another 6 to solve this. So this another 6 come from, let me jump through this first. So another 6 come from stress-strain relations. Stress-strain relations. So relating the 6 stresses to the 6 strain. So you have this 1, 2, 3, 4, 5, 6, or we put it in this way. Stress, strain is related to stress. 1, 2, 3, 4, 5, 6. So we have 6 equations from stress-strain relations, 6 equations from strain displacement relations, 3 equations from equilibrium equations. So you have total 15. So you have 15 equations. You have 15 unknown as a variables. So in principle, you can solve the problem. Okay. So these are the basic equations that we are going to look at next when I meet you again on Tuesday next week class. So we will look at a bit on how to get to these equations and some of the important things that we need to take note of, any assumptions that we make. Okay. Now, so that's all I would like to cover today. So I think you might have the next class to follow. So I will let you 5 minutes. You at least 5 minutes time to join the next class. So in next class on Tuesday, I will go through with you how to obtain these basic equations And also, meanwhile, please check your e-learning. I will be giving you some simple exercise problems so that you are more familiar with things that has been covered so far in this week. Okay. So with that, I would like to end this lecture this